Okay, I've had a few people ask me questions about getting started with the stoichiometry for the lab, where we reacted acetic acid with sodium hydroxide. And when you start any stoichiometry, make sure you've got your balanced chemical equation. When this reacted, it neutralized not both of them, but it's a neutralization reaction. And what we're trying to do is figure out how much sodium hydroxide of a certain concentration it took to neutralize all of the acetic acid. So we started with a volume of 25 milliliters, or 0.025 liters of acetic acid, and we wanted to know its concentration. With sodium hydroxide, we knew the concentration from the bottle was 0.500 molar, or moles per liter. And then we did the titration, and so liquid coming down in the burette, and we measured how much liquid there was. And we took an average of those two, and that average goes in right here. So say I had 17.4 and 17.6. Those were the two numbers that you were to use. You'd find the average of those. So you'd average 17.4 and 17.6, add them up and divide it by 2. I think that gives you 17.5. So to convert that to liters, it'd be 0.0175 liters. Okay, now we're not ready for stoichiometry. I forgot to write that whole equation out. I got all excited. So it's a double replacement reaction. So this piece goes with that, because acetate ion is negative and sodium's a positive. So those two will get to go together. So it'll be sodium acetate, aqueous, plus the hydrogen will go with the OH. So HOH, or water. Now sodium's a 1 plus and acetate's a 1 minus, so they balance. So I think that the coefficients for all of these are just 1. Okay, so since this is the one that I'm needing information, this will be my asked. That's where I'll end up. And I know information here, so this will be my given. So when I do the river, solid, liquid, gas, solid, liquid, gas, moles in the middle. I have liquid information here, so I'm starting at liquid. This side will be my sodium hydroxide side, and then this side must be my acetic acid side. Okay, so I'm going to use a formula to get to moles. That's step 1. And then I'll use another formula to get across the river, step 2. And step 3, I'm going to a liquid, so it'll be going to a concentration of acetic acid. Okay, so step 1. And on the river, they have the formula N is equal to capital M times V. That capital M we've replaced with C. So really the formula you use is N is equal to C times V. So step 1, I'm taking the concentration and volume of sodium hydroxide, and I'm getting moles of sodium hydroxide from that. Okay, I should have been using white. That's this step right there. Okay, so the formula I use is moles is equal to C times V. The concentration is right there, 0.500 moles per liter, times the volume is 0.01750 liters. Liters cancel. So how many moles is that? Let me get my calculator. So 0.500 times 0.0175. So that'll be 0.00875 moles of sodium hydroxide. Okay, step 1 done. Now, step 2, that's my red step. I'm going to convert the moles of sodium hydroxide to moles of the acetic acid. Okay, so I'm getting across the river. To do that, I write what I have, 0.00875 moles of sodium hydroxide. Then I'll multiply it by a mole ratio. So what I want goes on the top, that's the acetic acid. So 1 mole of acetic acid reacts with 1 mole of sodium hydroxide. It's 1 to 1, so the number will just be the same, 875 moles, but this time it'll be moles of acetic acid. Okay, step 3, the blue step, is to take the moles of acetic acid and use that and the volume that we put in the Erlenmeyer flask to figure out the concentration of the acetic acid. So step 3, I'm taking the moles and the volume of acetic acid, and I'm converting those to concentration of acetic acid. Okay, so my formula is C is equal to N over V. I don't have to manipulate the formula. Moles are 0.00875 moles, and the volume up there, 0.025 liters. So I'll take that number and divide it by 0.025. And I'm coming up with 0.175 moles per liter. And I would have to do my sig figs. I think it's 3 sig figs there. But that would be my concentration. Okay, hopefully that helps you with those 3 steps to figure out your concentration. And really your calculations will be exactly the same as mine, except this number you'll change to whatever your average volume that you used was. Okay, and then so this number would change, this number and this number would change, but then you divide by the same number there. Whatever you got there, you put there, divided by 0.025. Okay, hopefully that helps.